Hi everyone, hope you guys are having a fantastic day today. So this week we've been covering acid and bases, this week and last week. So today what we're actually going to do is we're going to talk about titrations. Okay, we're going to analyze how does a titration relate to acids and bases. Okay, and there's one equation, and actually the equation that we're going to look like kind of looks pretty similar to something we've already learned. Okay, so what I'm going to do is I'm going to present my screen. So today we're just going to take a little bit of notes about titrations. All right, so this is a sample of what a titration lab would look like. Okay, you got a tube called a burette, you got hydrochloric acid, and then you have an acid in the tube, and down here you have a base with some indicator, phenolphthalein. So you have an indicator. So titrations are used to find the concentration of an unknown solution of an acid or base. The concentration can be determined by carrying out a neutralization reaction. Okay, and we've been covering neutralization reactions this past week. We've been talking about how acids and bases create water and salt. Okay. So there's multiple steps. Okay, so an acid of a known volume, but an unknown concentration is added to an erlenmeyer flask. An indicator such as phenolphthalein is added to the solution. Measured amounts of a base of a known concentration are slowly added to the acid via a burette until the indicator turns pink, signaling that the endpoint has been reached. Okay, so that's the steps of how a titration process occurs. Okay, and this is what a graph looks like. Okay, so a graph of pH versus volume can be created using the data of a titration. So looking at this, you titrate, and then eventually it's going to turn into a base. Okay, it's going to turn into a base. All right, so if you look at this acid, the acid kind of, where it flattens out is about a 4-5. A 4 to a 5 is actually a weak acid. And the base flattens out about 14, which is a very strong base. So hopefully you remember in a neutralization reaction, when you have a strong base, a weak acid, the equivalence, the middle, is actually going to be a base. Okay. All right. And if you have to pause the video at any point to take some notes, that is absolutely fine. So the equivalence point. This point corresponds to the middle of the portion of graph, showing a very large change in pH with the addition of a small amount of standard solution. Since the indicator phenolphthalein is clear in acid and pink at base, the endpoint is noted when the solution turns its color, changes color from clear to pink. Okay. Equivalence point. Should the pH at the equivalence point always be 7? Well, no. We talked about strong acid with a weak base. Well, that would be acidic. If you have a strong acid, strong base, well, yeah, that will be around 7. Okay. Would the pH be less than or greater than 7 for a strong acid and a weak base? Well, strong acid's going to win, so it's actually going to be less than 7. Okay. What about this one? Well, hopefully you said with the strong base, it's going to be greater than 7. All right, so let's look at this. For each of the following graphs, determine whether the initial solutions were strong or weak and find the equivalence point. Okay, so this flattened out around 1 or 2. Is that a strong acid or weak acid? Well, that's very strong. Oh, wow, that's strong. So we have a strong acid. What about the base? Well, it's about 14. That's a strong base. Okay. whenever you get closer to 7, when you're close to 7, that's weak. We don't like it. That's very weak. Anything close to neutral is very weak. Okay. So the equivalence point, well, what's halfway between here and here? Say maybe this point right in here. So the equivalence point is actually a pH around 7. And we said strong acid, strong base. All right, so let's check this one out. Okay, well, my equivalence point is up here this time, right? Between here and here. I'd say it's above 8. Okay. Whereas if you look here, well, I have a weak acid and a strong base. Now, here's the equation I talked about earlier. When the acid and base react, the following formula can be used to determine concentration or volume. Remember back in the dilution chapter, M1V1 equals M2V2? Well, it's the same equation, just using acids and base. So we have molarity times volume of the acid is equal to molarity times volume of the base. Okay. So here, what is the volume of a 0.5 molar hydrochloric acid must be added to 25 milliliters of 2 molar KOH, which is a base, in order to make a neutral solution. Okay, there's my equation. So I have my molarity of my acid, and I have these two values. Okay. So since I'm solving for my VA, I have to solve for the volume of the acid. I got to divide my MA to the other side. Okay. And then when you plug in all your numbers, you get 100. Okay. So I want you to try this out, next problem out on your own. Pause the video if you would like. What is the molarity of a solution of HF if 30 milliliters of 1.5 molarity NaOH are required to neutralize 10 milliliters of the acid? Go ahead, pause the video. All right, so hopefully you worked this out and you used your equation and you got 4.5. Okay, that is all we're doing today. Okay, so hopefully that kind of made some sense. And you kind of understand the equation, all right? So from that, what we're going to do is we're actually going to do an online lab, but that will be on Monday, okay? So that's all the presentation. Well, yeah, we're going to do an online lab Monday, and we'll do a little practice tomorrow, okay? Yeah. So if you have any questions, please let me know. If not, have a fantastic day. There is no homework today. So we'll see you tomorrow.